Hello, my name is Jill Doherty, an engineer here at ON Semiconductor. Today we're going to discuss microcontrollers, some design considerations to keep in mind when implementing them, and some unique low-powered applications where they can be used. So why would you use a microcontroller over other devices in a design? This table shows a comparison of several factors you should consider in your design when making a component selection. As you can see, microcontrollers require less space because of their heavily embedded designs. This enables a designer to save board space as well as cost. If you are looking to accomplish a highly specific function or task, you have a few options. You can use a CPU, but these commonly don't include mixed signal functionality. So depending on the function you are trying to accomplish, you typically need additional components to provide functions such as sensing, power management, etc. In contrast, if you use a microcontroller, many of these functions will be integrated directly into the microcontroller, allowing you to reduce external components and save board space. Another challenge you may have to consider when choosing to use a microcontroller or MCU over an alternate solution is the amount and type of data to be processed and the speed required. Often speed comes with a related cost of noise in the system. For example, depending on the type of DSP or CPU you use, implementing these solutions sometimes increases the amount of noise in the system, thus decreasing signal integrity and power efficiency. Also, if you are implementing a time-sensitive system such as an airbag or an anti-lock braking application for automotive, or a safety sensor for a door or similar industrial automation solution, etc., you will want to ensure that you're using something that will provide you with a real-time operating system. From a power management perspective, you need to determine the number of functions you want to implement and different power requirements involved. You may be able to use a DSP with specific functions, but it requires longer design in time and less design flexibility than an off-the-shelf solution. If you use a CPU, it requires a bit more power, but it can accomplish a lot of calculations at one time. However, if your application does not require continuous calculations, a microcontroller is likely a more power-efficient choice. There are many different microcontrollers that serve a number of different purposes. A few of them are shown here. Each microcontroller has unique functions and integrated capabilities. A USB microcontroller provides communications that conform to the USB version 1.1 and 2.0 standards. It can be configured as a USB host or as a USB device. You may find these types of microcontrollers in healthcare equipment, audio equipment, personal computer subsystem controls, etc. General-purpose microcontrollers are suited for a wide variety of applications, including white goods and specialized equipment. These provide excellent cost performance in low pin count applications. Typical applications vary from audio equipment, home appliances, and communication equipment to personal computer subcontrol and security equipment. High-voltage microcontrollers support applications including automotive, lighting, audio equipment, home appliances, etc. LCD microcontrollers provide support for LCD driver circuits and applications like audio equipment, home appliances, communication equipment, and home care equipment. TVOSD, or on-screen display microcontrollers, provide functionality for text overlay applications in televisions. As you can see, microcontrollers can provide low-power, cost-effective solutions across a variety of end-market applications. Now I would like to turn some time over to my counterpart, Terada-san, to show us an example of an application featuring the LC87F7932B 8-bit microcontroller.
Hello, my name is Satoshi Terada. I'm Senior Application Manager with ON Semiconductor. Today, I'd like to introduce our ultra-low power microcontroller. Here is a demonstration. You can see the power consumption here. Just 1 microamp to drive this LCD as a clock. Actually, this demonstration has been running with the same coin battery in 4 months. And this solution is applicable for home security and portable equipment and metering solutions such as watering gas meters. Thank you.
This is just one of the many applications that can be designed using ON Semiconductor microcontrollers. We offer industry-leading, ultra-low power consumption microcontrollers that reduce standby mode power consumption by up to 85% compared to conventional microcontroller solutions. ON Semiconductor's high-performance 8-bit microcontrollers offer a low-noise design solution that reduces the influence of internal circuits on the oscillator and also provides low power consumption. We have the ability to create standard and custom microcontroller solutions that offer industry-leading low power consumption, high integration, and reduced space and component count. Depending on the complexity of the microcontroller required, these custom solutions can be implemented very quickly. Software, hardware, and customer support for these standard and custom microcontroller solutions is available. For more details regarding ON Semiconductor microcontrollers, contact your local ON Semiconductor sales representative or authorized distribution partner, or you can visit our website at www.onsemi.com. Thank you.